There's lots of ways to deal with artifact analysis, and this is basically what you just went through. I collected the artifacts for you. You basically did a surface analysis, and we'll talk about more of these in detail. You can run it, and you can do static analysis. Some of you talked about doing a reverse engineering or trying to do reverse engineering. That's kind of a static analysis where you're trying to determine what the actual code was within the malware. So with surface analysis, let me suggest that you just did a surface analysis of what I called a piece of malware. You looked at it, and you said, I wonder what this is. It's got rubber. I think that goes in a wet environment. It's got these sort of characteristics. You didn't do anything to it except look at it, and that has a lot of value. Typically, it takes text files, source code if you can find them. Has anybody used the strings command in Unix, which is also available in Sigma? Tell me what it does. What does strings do?
It takes an executable, you run the string command against executable, and you see all the actions.
It just gives you every string it can possibly find.
And defines string.
ASCII.
ASCII. It probably works on Unicode also. I never.
So it prints out sequences of printable ASCII strings 4 or more characters long by default. So if you ran strings on a text file, it's going to give you the whole text file because it's all ASCII. But if you ran strings on a binary file, it's going to find those parts of a binary file that are ASCII. So it's not going to give you any of the funny printable characters. If you printed it out on a line printer, it's going to give you garbage. It's only going to go the strings. What would you expect to find in there?
Comments. Yeah.
Comments.
IP addresses, domains.
IP addresses, domain names that would be used as the rendezvous place to send something back to, maybe URLs. Maybe you're going to find passwords to sites. So if you just ran a simple strings, did a simple surface analysis on that malware, you may find some information that helps you maintain the velocity of the investigation by finding out who, where it's sending, what IP addresses, and perhaps what credentials. And strings is non-destructive. Doesn't change the executable. It will change the timestamps because you're accessing a file no matter what the system is. So you're changing some evidentiary value, but you're running it on a copy of your original evidence anyway, so that's okay. You can, for example, run an MD5 checksum on it. I did this for a class. I don't know if I said this to Robin last night. I took a screen capture. I then brought, not a screen capture, a network capture. I then brought it into Wireshark. I assembled a TCP stream. I found in that TCP stream that there was some binary information. I cut that out with Wireshark. I saved it in a file. I ran an MD5 checksum on that file, and I pasted it into Google. All this is easy to do. It's really, you might not have done it, but trust me, it's easy to do. When I pasted it into Google, I got back an answer that says it's this kind of malware and this is what it does. And it was trivial, from the network capture to a full explanation of what it was based on an MD5 checksum. Very easy to do. So you can do a checksum, file size, probably less the case, file name. Did you ever get a DLL on your system and you did a Google on the DLL to see what it was? Same deal. You find a mumble.exe, do a grep on or Google on mumble.exe and find out what it is. The point is there's lots of things that you can do that are easy to do malware analysis just by doing a surface analysis. All an MD5 checksum is read it and compute a sum. Non-destructive, no big deal. I like the idea of taking it to Lowe's because that's essentially an MD5 checksum. I know what it looks like. I want to find something else that looks just like it based on a checksum. In this case, it's visual. Oh, it's this. Now I don't have to think of anything else. Very good idea. Public sources. So once you get some of this, now you can say, oh, it's this DLL. Let me look at vendors. Let me look at AV sites. So, and this is what a system that we have that's called MCARTA, which stands for something that I can't remember off the top of my head. Malicious code, automated something mumble. The point is it does a surface analysis, does a very quick amount of things on a piece of malware, gives you an answer in 10 minutes. So law enforcement can submit something to it, then get an answer back via email very quickly and say, okay, now we know what we need to do next. And in many cases with malware, that's enough. Sometimes you'll need to reverse engineer it and go all the way and see if you can understand the algorithms, but you may not in most cases. Comparative analysis. Compare it against something else. Maybe this is the Lowe's example. I don't know what it is. Let me go to Lowe's and see if I can find something else that looks like it. runtime analysis, let's run it. So you could take that piece of malware and you could put it in every place in my house that looks like it fits until it actually did something that was meaningful, for example. The challenge of doing runtime analysis is quite a few, and we'll talk some more about that. It may do bad things wherever it is, so you need to put it in a place where the bad things that it does are okay. But you may also find that it requires a bunch of stuff for it to act in a certain way, like it makes DNS requests. There better be a DNS server where you're running it. It makes DHCP requests. It makes SMTP requests. So it needs to be in a position where it can do its thing. Now, it's also the case that modern malware writers can recognize when they're running in virtualized environments. So they may say, oh, I'm running under VMware, I'm not going to do anything. Or I'm not running in the right IP address range, I'm not going to do anything. Tell me an example that we all know of where that was the case. Recent example, worldwide, well known. Nuclear power plants. Stuxnet. Stuxnet only did its thing when it was in the right place, and it was benign elsewhere. So it could tell, based on whatever characteristics, that it was where it needed to do its thing. Static analysis. Now what I'm going to do is I'm going to take that binary, I'm going to turn it into machine language, and I'm going to take that machine language and turn it into a higher level language by hand or automatic, and then determine what the algorithms are within that code and determine what this thing is really doing. That's not easy. That's not for the faint of heart. If you are interested in doing more malware analysis, we have a malware apprentice program that the SEI teaches here, and it's on our website, and I think it's a 3-day class, but I'm not sure, and it's taught, I think, in DC this year 3 times. So if you want to get into malware, that's one good way to do it. I don't teach that, somebody else teaches that.
The same like some of the SANS course?
My understanding is that it's more detailed than the SANS course. Excuse me.
And I think that the course itself is limited to U.S. government and law enforcement.
What's the title of the course? What's the title of the course again?
A malware apprentice program, I think. I'll look it up here after. It's on our, if you go to cert.org and look at training, you'll get the 2012 training calendar. It's out on that. So here are some of the tools if you are doing static analysis. Debuggers, and again, it is possible within a Windows program, for, among others, to determine if you're running under a debugger. So if I'm a bad piece of software and you're trying to debug me, I'm going to act like a good little boy, and I'm not going to do anything bad. So I'm going to make your debugging operation benign, and you're not going to learn anything. These are other pieces of tool. One of the ones that I hear people use a lot is IDA Pro. I have no experience with IDA Pro. I just hear a lot of people talking about it. So it's important to understand all of this stuff, and that is you got to know the underlying hardware. You got to know what the significance of registers and bits within registers and status bits and instructions and all that stuff. So if you want to do this, you really got to know the Intel instruction set really quite well and what it means, and then understand what system calls in Windows do, et cetera, et cetera. You really have to know that stuff quite well. But it's a lot of effort. It's well worth it because there's a lot of malware to be analyzed, but it's well worth the time to do that.